Natural monopolies. Now, in a previous lesson, we discussed monopolies' efficiencies, and we came to the conclusion that monopolies are neither productive or allocatively efficient, but they can be dynamically efficient. So now, if all monopolies are neither productively or allocatively efficient, why do natural monopolies exist? The reason for this, natural monopolies exist as it's naturally most efficient for one firm to control the entire market, so have 100% market share. And there are quite a few examples of natural monopolies, but especially if you're from London, what's a big example of a natural monopoly? TfL, or you may know it as Transport for London. Now we're going to go a bit more into depth with TfL because it's an absolute perfect example of a natural monopoly. So why is TfL a natural monopoly? So try to think about the sector that Transport for London is in and why it makes it inefficient for another firm to join the market. So for example, the extreme high costs of constructing and maintaining these underground stations makes it impractical for new firms to operate competing underground networks, and it also means it's very inefficient, meaning that it's naturally most efficient yet again for TfL to control the market. Now, building on that, natural monopolies usually have two common features or characteristics we see in all of them. Now, what do you think these are? Firstly, it's the high costs, or more specifically, the high sunk costs. For example, in the example of TfL, so we're almost building like a little bit of a case study here, but in TfL, of course, they run trains, so all the train tracks they had to put down, they're all sunk costs because if they leave the market, they will not be able to recover the costs from them. Then, of course, controlling the entire market does not come without its perks. And what do we call it when a firm increases their output and this decreases their long-run average costs? Yes, is economies of scale, and natural monopolies won't have small economies of scale, they have huge economies of scale. Big one, and an example I'm sure you'll know, is a technical economies of scale, so investing into specialist capital machinery. And for example, in our lifetimes, we've seen train stations move from human capital, so human people checking your tickets, to now more machinery and more just scanning your tickets at barriers. So let's go a bit more into depth with each of these features. So why are high sunk costs a feature of a natural monopoly? And this is referring to why it is efficient for only one firm to have to pay these, as only one firm would have to pay these huge sunk costs, and it would be extremely inefficient if another firm had to pay these. As imagine if, especially with the limited space you have already in London and how crowded the London Underground is already, imagine the Underground was run by several different companies whose routes didn't cross. It would just lead to absolute mayhem and overall just lead to much worse outcomes for consumers. Then just putting the ticket scanner example I mentioned earlier into words. So to lower long-run average costs, natural monopolies exploit their economies of scale. I really like that key term with exploiting their economies of scale. So running it down as much as possible, and of course the example, invest into ticket scanners, moving away from human workers, meaning that it lowers their costs exponentially over time, as a ticket scanner will require maybe some upkeep, but human capital of course will require a lot more demanding hourly wages. So like we always say, it's all good knowing the content knowledge, but a diagram to back it up can really help. So let's move on to the natural monopoly diagram. Natural monopoly diagram, let's get on with it. On your y-axis, you have cost / revenue, and on your x-axis, just like for monopolies, you have quantity. So the only real difference between natural monopoly and monopoly diagram is two unique curves. And these are both of your cost curves. So your average cost curve and your marginal cost curve. And the only thing you need to remember with these two is that now they look like L shapes. So your first curve looks something like this, and like I was saying, just L-shaped, so I'll label this LRAC, that's your long run average cost. Then I said both cost curves are L-shaped, so now we have our LRMC, which is just your marginal cost curve, and all you need to do, the only rule for this, is just going to be vertically below your AC curve, so just look something like this. And yeah, that would be your LRMC curve. And that's all the L-shaped curves done for your natural monopoly diagram. Now, all you need to do is complete this diagram just like you'd complete the monopoly diagram. So we have two curves left. We have our demand curve, so D equals AR, and we have our MR curve. So let's add these now. So just like I said, normal diagram, so demand equals AR. Then your marginal revenue curve, again, same rules that applied before, and MR curve. And now that's your completed natural monopoly diagram. Now there's lots of additions you can make to this diagram, which we'll cover in a future video. But the simple one, and the one you're going to use the most, is just the classic economic assumption. What are firms? They're profit maximizers, and they do that where MC equals MR. Now let's find where this is on this diagram. So we have our LRMC, which is just still the same, still that MC curve, and an MR. They intersect here, so that would be the profit maximization point where MC equals MR, but still same rules apply. You don't go left from there. You have to keep going up until you hit your AR curve, and then go left from there. And now this would give you P max. It's your price at where a natural monopoly would profit maximize, and then of course go down from there to find your quantity at where the firm would profit maximize. Then now, how would we find our box of supernormal profits? Just like before, go from your Q max quantity up until you hit your AC curve, go left from there, and this would now be your box of supernormal profits. Also, just a few points to mention with your natural monopoly diagram. Of course, if you're looking at your LRAC, you can of course see there are no diseconomies of scale here. So they go through economies of scale, but they do never suffer diseconomies of scale. And also there's just a little bit on the MES, which is the minimum efficient scale. This is where a firm first hits its lowest long run average cost. So anywhere around here, doesn't have to be 100% accurate, would probably be the firm's MES, because that's where a firm first hits its lowest long run average cost. Okay, so just a written recap on the natural monopoly diagram. So of course, like I always say, focus on your axes: y-axis cost/revenue, x-axis quantity. Secondly, like I referred to when we were drawing the diagram, in natural monopolies, you have two unique curves here. You have your long run average cost and your long run marginal cost, and these are both L-shaped curves. So now, what's the difference between your LRAC and LRMC? Is your LRMC is just vertically below your LRAC at every point. Then it's just a simple, normal, demand equals AR curves and MR curves. Then just adding on the box of profit maximization. So just a little tip here, make sure you've done enough practice drawing the boxes of supernormal profit on natural monopoly diagrams, because they are slightly unique compared to your other diagrams. And then lastly, just the two little bits I mentioned at the end. Your LRAC curve keeps going down until you hit your minimum efficient scale. And the way I would define the minimum efficient scale is the point where a firm first hits its lowest long run average cost. And the emphasis is on the word first. And then one of the main positives of natural monopolies, they do not suffer from diseconomies of scale.